What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 11, Section 8, Solving Systems with Cramer's Rule. Let's do it. Question 1. Explain why we can always evaluate the determinant of a square matrix. So when you look at the little infographic for Cramer's Rule, and by the way, I'm going to show you different ways as well to calculate the determinant, but this is one example, and you see what you're doing is it's 5 times this little square here, right, the determinant of that, and then it's minus -3 times, you see how it's color-coded? 2, 7, -5, -2, etc. And so what you're doing is you're kind of multiplying against these little mini determinants and then adding or subtracting, whatever, combining it. So the bottom line is when you have a square matrix, whether it's 2 by 2, 3 by 3, etc., you're going to be able to follow these steps and carry out these calculations. So anyways, that's how you do it. Done. So if a matrix has a determinant of 0, it means that the inverse of that matrix does not exist. So to find the determinant of a 2 by 2, you say this times that, so 1 times 4, and then it's minus this times this, so minus 3 times 2, so that's 4 minus 6, which equals a determinant of -2, boom, done. So once again, for a 2 by 2, we do A times D, or in this case, 2 times 6, minus, and then we do C times B, so that's -1 times -5, like so. 2 times 6 is 12, minus -1 times -5 is 5, which gives a determinant of 7, boom, done. To find the determinant, we do this times this, which is 1 times -4, minus this guy times that guy, right? 3 times 0. That, of course, is just 0, so our final answer is -4, boom, done. So for this one, to find the determinant, once again, we do 10 times 0.1, right? Which is, again, A times D minus C times B, which is 5 times 0.2. And that gives us 1 minus 5 times 0.2 is also 1, and that gives us a determinant of 0. Boom, done. So for this one, we do that times that minus that times that. So -2 times 4,000, this is just the basic way we calculate a determinant, minus 3.1 times -3. So -2 times that is -8,000. -3.1 times -3 is positive, right? Because it's going to be that minus and a negative there, so they're going to cancel out. So plus 9.3. So basically, this is going to be like 8,000 minus 9.3, except the final answer is going to be negative. So it's -7,990.7. That's how you do it. Done. So for the 3 by 3, what I'm going to show you as a really nice method to calculate this determinant is basically to repeat these first 2 rows right here. So watch this. I'm going to say -1, 0, 0, right? Repeating this first column. And then I got 0, 1, 0, repeating that first column, okay? And then what we're going to do is we're going to do some diagonal multiplication. I'm going to show you what I'm talking about here. So we're going to do this strip multiplied plus this product, all those multiplied, plus this product, and then we're going to say minus this product, minus this product, minus this product. So let's write that out. So -1 times 1 times -3, that's just +3, plus 0 times 0 times 0, which is 0, plus 0 times 0 times 0, which is 0. Now we're going to go to the reds. So now we got minus 0 times 0 times -3, which is 0, minus -1 times 0 times 0, which is 0, minus 0 times 1 times 0, which is 0. So obviously all the zeros don't really matter, and we're left with the final answer of 3. That's the determinant. That's how you do it. Done. So for this one, to start it out, I'm going to repeat these first 2 columns. I'm going to say 1, 0, 1. That's the first column again. And then the second column, 0, 1, 0. And then what we're going to do is we are going to look at diagonal products, right? We're going to take this product plus this product plus this product, and then coming back the other way, minus this product, minus this product, minus this product. So let me show you what I'm talking about here. So 1 times 1 times 0 is 0, plus 0 times 0 times 1 is 0, plus 1 times 0 times 0 is 0. So those are all zeros. And then we're going to minus 0 times 0 times 0, which is 0, minus 1 times 0 times 0, which is again 0, minus 1 times 1 times 1, which is 1. So you can see everything kind of doesn't matter because they're all zeros except this -1 at the end. So the final answer is a determinant of -1. That's how you do it. Done. So for this one, again, we're going to start by repeating column 1 and column 2 right here, right? So we got -2, -4, 2. That's column 1. And then that one, 1, 2, and -8. And now we're going to do some nice diagonal products. So we're going to do this product plus this product plus this product, and then we're going to say minus this product, minus this product, minus this product. So let's write that out. So we're going to do a little mental math here. We got -2 times 2 times -3, which is positive 12, plus 1 times -8 times positive 2, which is -16, plus 4 times -4, which is -16, times -8, which is positive 128. Now we're going to minus the ones in the red, minus 1 times -4 times -3, which is positive 12. So we're minusing that. Again, we're minusing -2 times -8, which is 16, times -8, which is negative 128. Again, those are going to cancel out, but we'll get to that in a second. Then 4 times 2, which is 8, times 2 is 16. So we're minusing 16. So now let's combine everything. So we got 12 and -12, those are going to cancel out. We got -16 and 128, that is 112. Again, this becomes a plus 128. And then last, we're going to minus 16. So that's going to make 240 minus 16 with a final answer of 224. That's how you do it. Done. So for this one, to start calculating the determinant, we got to start by repeating column 1 and column 2 right here. So now that we got that written in, we're going to calculate some products via diagonal. So we got this product plus this product plus this product. So in blue, we're going to be adding them. And then in red, coming back the other way, minus this product, minus this product, minus this product. So I'm going to show you how to calculate this now. So now for the first product, 5 times 3, which is 15, times -3 is -45. Again, these are all going to be added together, the blue ones, plus 1 times 1 times 3, which is 3, plus -1 times 2, which is -2, times -6, which is positive 12, okay? Now we're minusing whatever is in red. So minus 1 times 2 times -3, which is -6, minus 5 times 1, which is 5 times -6 is -30. And then minus -1 times 3, which is -9. All right, now we're going to combine everything. So -45 plus 3 is -42, plus 12 is -30. And then we got plus 6 plus 30, which is 36, plus 9, which is 45. So we combine -30 plus 45, we get a final answer of 15. That's how you do it. Done. So to calculate the determinant here, we need to add column 1 and column 2 right here. So let's do that now. And then we're going to multiply this plus this product plus this product. And then we're going to subtract this product, and this product. So first we got 2 times 3 times 2, which is 12, plus -1.6 times -8 times -9.3. Using a calculator, we get -119.04. And then we're going to add this product, 3.1 times 1.1 times 0, which is just 0. Next, we're minusing this times this times this, which is going to give us -3.52. Minus, this is going to be 0 because of that 0. And then minus, that's -86.49. And there we go. Again, these are going to turn into a plus. These are going to turn into a plus. All right, let's calculate it. So when we add everything together using a calculator, we get a final answer of -17.03 for the determinant. Boom, done. So now we're going to use Cramer's rule to solve this system. And the way we're going to do it is we got to come up with a series of matrices, come up with their determinants, and then we're going to use the determinants to solve for x and y. So first we're going to have our original matrix with the coefficients 2, -3, 4, and 5. Then we're going to have a second, we'll call it the X matrix, okay? What we're going to do is we're going to take these constants right here and we're going to replace the X column with those. So we got -1 and 9, and we're going to leave the -3 and 5 like so. And then we've got the Y one, okay? And then again, we're going to take these and we're going to replace the Y's. So we got 2, 4, and then instead of -3 and 5, we got -1 and 9, okay? And now we're going to calculate the determinant of each of these. So we got the main determinant of these coefficients. So again, it's going to be 2 times 5 minus 4 times -3. So it's going to be 10 minus -12, which gives us 22. Okay, so this is that determinant. Then this one is going to be -1 times 5 minus 9 times negative 3. So that's negative 5 minus negative 27. That turns into a plus. So again, we have 22. Very interesting. And then over here, we have 2 times 9 minus 4 times negative 1. So that's 18 minus negative 4. So look at that. All three are 22. Okay, now to get our x value, we take the determinant of the x matrix, which is 22, and we divide it by the determinant of the original matrix, which is 22. And that's our x value, and that's just going to reduce to 1. So x is equal to 1. Now for the y value, we take the y determinant, which is 22, divided by the determinant of the original matrix. So again, that's going to be 22 over 22, which is also 1. So we have 1, and 1 is the solution. So last but not least, placing this in coordinate format, we got 1, comma 1. There's your solution. That's how you do it. Done. All right, so for this one, we're going to make 3 different matrices, okay? So first we got with the regular coefficients 6, negative 3, and that's on the left side, right? Negative 8 and 9. And we're going to calculate the determinant of this. Then what we're going to do is we're going to calculate the determinant of, we can say like the x matrix, okay? So what we're going to do here is we're going to replace the x's with these values. So we're going to have 2, negative 1, and then the y is negative 3. And 9. And then we're going to calculate, let's say, the determinant of this y matrix, where we take that same matrix and we leave the x's in the mix and we replace the y's with these constants, 2 and negative 1. Okay, now we're going to calculate the determinants for all of these. So again, we multiply 6 times 9, which is 54, minus negative 8 times negative 3, which is 24. That gives us 30. Okay. Then we're going to calculate this determinant. We got, boom, multiply 2 times 9, which is 18, minus negative 1 times negative 3, which is 3. And that gives us 15. And then we got this one down here. We got 6 times negative 1, which is negative 6, minus negative 8 times 2, which is negative 16. That becomes a plus. Negative 6 plus 16 equals 10. Okay. All right. Now to get our values of x and y, we take dx 15 and divide it by the original determinant. So x is equal to 15 over 30, which is just 1/2. And then y is equal to 10 over 30, this one, right, which is going to be 1 over 3. So then our final answer is 1/2, comma 1/3. That's how you do it. Done. So for this one, we're going to set up 3 different matrices. The first one, we're going to take these coefficients right here, just as is, 4, 2, 3, negative 1, and we're going to calculate the determinant. We're going to come back to that. We also need to set up a second and a third matrix. The second one, we're going to replace the x. We're going to call it the x determinant. So we're going to replace the x with these constants right here. We got 23, negative 1, and then we leave the 3 and the negative 1 as is. And then we're going to do it for the y's, okay? So we're going to replace the y's, keep the x's, 4 and 2, replace the y's with these guys. So then we have 23, negative 1. Okay, now we're going to calculate each of these determinants. This times this minus this times this. So negative 4 minus 6, which is negative 10. Then we got for dx, 23 times negative 1, negative 23, minus negative 1 times 3, which is negative 3. That's going to be a plus. Negative 23 plus 3 is negative 20. And last but not least, we got the dy. So we got 4 times negative 1 minus 2 times 23. So that's negative 4 minus 46. And that's going to equal negative 50. Okay. Now to calculate my x value, I take the fraction or ratio of negative 20 over this d value, which is negative 10. And that's going to equal 2. And for y, it's going to be this value, negative 50, over that same d value, which is negative 10. And that's going to be 5. And we're a little cramped for space here, but it's going to be 2 and 5. So our final answer in coordinate form is 2, 5. That's how you do it. Done. So for this one, we're going to set up 3 different matrices. The first one is we're going to take 4, 2, negative 3, 6, right? All those coefficients to the left side of these equations. We get negative 3 and 6. Then we're going to set up dx, determinant x. And to do that, we're going to take that and replace those constants or use those constants to replace these coefficients. So we got -3, -4, right? We slide it into the x positions, and then we got -3 and 6. We leave the y's alone. And then we got dy, okay? So again, we leave the x's alone, the 4 and the 2, and then we pop these in, and we got -3, -4. Now let's calculate each of these determinants. So we got 4 times 6 minus 2 times -3. So that's 24 minus -6, which if you add those, that's going to be 30. And then we got -3 times 6 minus -4 times -3. That's -18 minus +12, which is -30. And then we got this one, 4 times -4 minus 2 times -3. That's -16 minus -6. It's going to be a plus. -16 plus 6 is -10. Okay. Now to get x, we take the dx, right? -30 over the original d, which is 30, and that gives us a -1 for x. And then for the y, we take -10, this one, dy, over the d, which is 30, and we get -1/3. So our final answer in coordinate form is -1 for x, -1/3 for y. That's how you do it. Done. So for this one, first we're going to set up our little matrices, 2 by 2s, right? First we have with those coefficients of the x's and the y's on the left. So we got 4, 10, -3, and -5. And we're going to calculate the determinant of this. Then we're going to do the same matrix with the same y values, 10 and -5. But now we're going to replace the x's with what we have over here, which is 180 and -105. And this is going to be what we'll call the determinant for x. And then we're going to do one more matrix where we're going to have the x's, the 4 and the -3 right here, right? But we're going to replace now the y's with 180 and -105, and let's call this determinant y determinant. Okay, let's calculate all of these, and we're going to do 4 times -5 minus -3 times 10, which is -20 minus -30. That turns into a plus. -20 plus 30 is 10. Okay, now let's do dx. This times this, that's -900 minus that times that, which is -1050. Turns into a plus. -900 plus 1050 is +150. And then dy, this times this is -420 minus this times this, that's -540. Boom, boom. That turns into a plus. -420 plus 540 is +120. Okay. Now to get my x value, I do dx divided by d, right? dx divided by d, that's 150 divided by 10, which is 15. And then to get my y value, it's dy divided by d, which is 120 divided by 10, which is going to be 12. So then my final answer in coordinate form is 15, 12. That's how you do it. Done. For this one, we have a triple system, right? 3 equations. And again, we're going to use Cramer's rule. So the main idea is we got to calculate dx, dy, dz, and then the determinant of this original matrix like that. And then once we get all of those, same method applies, right? dx divided by d gives us our x value. dy divided by d gives us our y value, and so on. So first, let's do d. So we're going to set up that matrix. So we got all of these coefficients here. 1, 2, -4, 7, 3, 5, and then -2, -6, and 7. Now to calculate the determinant, we basically repeat those first 2 columns. So 1, 7, -2, and then we've got 2, 3, -6. Okay, so it's going to be D, and then I like to color code it. So we're going to do the product of this, this, and this. The blue ones, we're going to add those products, and then we're going to take minus that product, minus that product, and minus that product. Okay, let's write it out. So 1 times 3 times 7 is 21, plus 2 times 5 times -2, that's -20, plus -4 times 7 is -28, times -6 is +168. And then we say minus 2 times 7 times 7, that's -98. 1 times 5 times -6, that's -30, and we're minusing it again. All in the red, we're minusing. And then -4 times 3 is 12 times -12 times -2 is +24, so -24. So 21 plus negative 20 is 1, plus 168 is 169. And then this is going to become a plus, by the way. So then we got plus 30 is 199. And then we got a negative 98, negative 24. That's a negative 122. So we're basically subtracting those, and we got 77. So D is equal to 77. We're going to come back to that. Now to get dx, what we're going to do is we're going to replace this, basically that column, with this column. So we're going to write that down below. So what you can see here is we have the exact same matrix down here as we have up here, except I replaced this row with those coefficients, or sorry, not coefficients, constants on the right-hand side. So this is going to be d of x. Now we got to calculate this determinant. And just like up top, we got to repeat these first two columns here over here. Now that we've got this set up, let's do our same thing with the highlighting. So we got this product plus this product plus this product, and then we're minusing this product, minusing this product, and then minusing this product. So we got first negative 21 for that guy. Then we got 2 times 5 times negative 6. That's negative 60. And then we got negative 4 times negative 6, which is positive 24. And then 24 times 26 is 624. Okay, now the reds. So we got this one would be 2 times 7 times 26 is 364. But again, we're minusing all of these. 1 times 5 times 6, those two negatives will cancel out. So that's 30. So we're minusing 30. And then last but not least, 12 times 6 is 72. Positive, right? Because the negatives cancel out, but we're minusing it. So minus 72. And then we have positive 77 when you combine all this together. So that's dx, determinant of x. Now to do d of y, we come back to the original matrix that we had here. And now what we're going to do is we're going to replace the y column with these constants. So let's write that out. So here we have the good setup for dy. And again, we've replaced this column with the constants on the right-hand side. And now we're going to repeat out these two columns over here to get the determinant. And now we're going to multiply, multiply, multiply all of those products. Each of those three products, we're going to add them. And then we're going to minus this product and minus this product and minus this product. So let's write those out. So 1 times 26 times 7 is 140 plus 42 is 182, positive. Negative 1 times 5 times negative 2 is positive 10, and we're adding it. So then we got negative 4 times negative 6, which is 24 times 7, 140, 168. And then now these products in red, so negative 1 times 7, that's negative 49, but we're minusing it, so minus negative 49. 1 times 5 times negative 6, that's negative 30. Again, we're minusing that. And then negative 4 times negative 2, which is 8 times 26 is 160 plus 40 is 208. So we're minusing a positive 208. So add these blues up, we get 360, and then that becomes a plus 79, which is 439 minus 208, which should give us 132. So 231 for dy. All right, now coming back to the top, we need to get dz, and it's again going to be the same as this matrix, except now we're replacing this. We're replacing the z's with negative 126, negative 6, so let's write that out below. So now here we have it for dz, and then we're going to repeat column 1 and column 2 over here. So we have 1, 7, negative 2, 2, 3, negative 6. And now let's calculate these products. So again, in blue, we're going to add these positive, products, boom and boom, like that diagonal. And then we're going the other way. Everything is red. We're going to subtract those products, boom, boom, and boom. Okay. So now we have 1 times 3 times negative 6. That's negative 18. Again, we're adding it, so it stays negative. 2 times 26 times negative 2. That is negative 104, so we're adding a negative 104, and then negative 1 times negative 6 is 6 times 7 is 42. Okay, now to do the reds, and we're minusing all those. 2 times 7 is 14 times negative 6 is negative 84, and we're minusing that, right? And then 6 times 26, 120 plus 36, 156, and times 1, but it's negative, so negative 156. And then we got negative 1 times negative 2 times 3, which is is positive 6. So we're minusing that positive 6, negative 6. And then as we simplify, that's negative 122 plus 42 is negative 80. And then we're adding a positive 84 here, right? That becomes a positive, and that becomes 4. We're adding a positive 156 plus that is 160. And then we're minusing 6 from that, and that's 154. So there we go. There's dz. Now we've got our values. We got dy 231, dz 154, dx is 77, and the original d is 77 as well. Okay, let's write these down below. Now that we have these values to get x, we take dx divided by d, which is just 77 over 7, which is 1. We take dy divided by d to get y, and that is exactly 3 on the money. And then last but not least, to get z, we get dz divided by d, which is exactly 2. So our final answer is x equals 1, y equals 3, z equals 2. That's how you do it. Done. So for this one, we got another triple system. So we're going to set this up in a matrix. We're going to get the original determinant, then we're going to get determinant of x, determinant of y, determinant of z, and that will help us to solve for x, y, and z. I'm going to show you how to do everything now. So first, let's get the main determinant, and we're just going to make a matrix involving the left side. So let's do that now. So we're putting in those coefficients. We got 4, 5, negative 1, right? Negative 2, negative 9, and 2. And here there is no x, so that's a 0 for the x. And then we got 5 and 7 for y and z coefficients. Now we're going to repeat these first two columns like so. And then we're going to get the products going on this diagonal, and this diagonal. And every one of these products in blue we're going to add. So we're going to take those versions and just add them. And then we're going to come the other way and get that diagonal product, and that one. And we're going to subtract each and every one of those. So let's write this out now. So we got 4 times 7 is 28 times negative 9 is 180, 72, negative 252. And then we got 5 times 2 times 0 is 0. And then negative 1 times negative 2 is 2 times 5 is 10. And then we are going to minus all these in red. So that's negative 5 times negative 2 is negative 10 times 7 is negative 70. But we're minusing that. So minus negative 70. And then we got 4 times 2, which is 8 times 5 is 40, minusing 40. And then this times 0 is 0. Okay, now let's combine it all together. We got negative 242 and then plus 70 minus 40. That's 70 minus 40 is 30. So negative 242 plus 30 is negative 212. So that's my d. Now we got to get dx, dy, dz. All right, so to get dx, what we're going to do is we're going to follow that same procedure, but when we write our original matrix, we're going to replace the x column with the constants on the right-hand side. So let's do that now. So you can see this is basically the same as this. Again, we replace that first column with those numbers. And now let's repeat the column 1 and column 2 over here, and then we're going to calculate the determinant. So we do this product plus this product plus this product, and then we subtract that product and subtract that product and subtract that product. Okay, let's write it out. So 7 times 7 times 9 is 441. Again, the negatives cancel out. And then we got 5 times 2, which is 10 times 21 is positive 210. Negative 1 times 8 times 5 is negative 40. Okay, and again, we're adding negative 40. So I just wrote minus 40. Now we're going to do these ones. 5 times 8 is 40 times 7 is 280, but we're minusing it. So negative 280. And then 5 times 2 is 10 times negative 7 is negative 70, but we're minusing negative 70. And then last but not least, negative 1 times negative 9 is 9 times 21 is 189. And again, we're minusing that. And when you combine everything together, we get positive 212. So this is my dx. Okay, let's do dy now. So going back to the top, again, we're going to have the same matrix here, except we're replacing the y column now with these constants. So let's write that down below. So once again, here we put in that middle column of those constants, and everything else is the same compared to the first matrix. And then we're going to repeat column 1 and column 2. And then we're going to multiply. So those products are going to be added, and then we're going to come back the other way. Product, and those are going to be subtracted. So let's write that out. 4 times 8 is 32 times 7 is 210 plus 14 is 224. Negative 7 times 2 times 0 is just 0. And then negative 1 times negative 2 is 2 times 21 is positive 42. And then we're minusing negative 7 times negative 2, that's 98, but we're minusing that. 4 times 2 is 8 times 21 is 168. We're minusing that. And then this times 0 is 0. So now we combine everything. The positive 224 and 42 is 266. And when we add this and this together, that's negative 266. So these cancel out to just a 0. So dy therefore equals 0. And now we're on to the last one, dz. Once again, we're starting with this original matrix, but now we're replacing the z column with these constants right there. So let's write that down below. So now we got this set up for dz, and then we're going to repeat these first two columns. Now we're going to multiply, and then we're going to, those products, we're going to get those products and add them, and then we're going to multiply, and then we're going to take each of those three products, but we're going to subtract them. So we got 4 times 9 times 21, which is 756, but because of that 9 is negative, it's negative. 5 times 8 times 0, that's just 0. Negative 7 times negative 2 is 14, times 5 is 70. Now we got the reds. 5 times negative 2 is negative 10, times 21 is negative 210, but we're minusing that, right? And then we got 4 times 5 is 20, times 8 is 160. We're minusing that. And then negative 7 times negative 9 times 0 is 0. So this becomes a plus. And when we simplify this, we get negative 636. Now we're going to write out dx, dy, dz, and the main determinant below, and then we'll do our calculations. Now to get our final answers for x, y, and z, we take each of these values and divide by the d. So 212 divided by negative 212 is negative 1. 0 divided by that is 0. And then negative 636 divided by negative 212 is positive 3. So there's x, y, and z for your solution. Boom, done. So for this one, we're going to start by calculating the determinant and dx, dy, and dz. And that's how we're going to find our solution using Cramer's rule. So first, the original matrix for d I'm going to set up is with all of these coefficients on the left-hand side. So we got 4, negative 2, and 3 for the top equation. Here we got negative 6, 1 for y. And since there is no z, we got a 0. And here we got 2, 7, and 8. This is going to be the main determinant. Now to calculate that, we're going to also repeat the first two columns over here. And then we're going to do product. We're going to add all the ones in blue. And then we're going to do product, come back the other way. Product. All the ones in red, we're going to subtract. So we got 4 times 8 times 1 is 32. Negative 2 times 0 times 2 is 0. 3 times negative 6, negative 18 times 7, 70 plus 56, negative 126. And of course, we're adding that, but it's still a negative. Now we do the reds. And we got negative 2 times negative 6 is 12, times 8 is 96, but we're minusing that. 4 times 0 times 7 is 0. 3 times 1 times 2 is 6, and we're minusing that. So we got negative 94 for the blues, and then here we have negative 102, both negative, so we're adding them together, and we get negative 196 for D. Now we're going to calculate dx, so we're going to make some room, and with dx, we're going to do the same matrix that we have here, but we're going to replace the x column with these on the right-hand side, 6, negative 224. Let's write that out now. So again, we're going to repeat first and second column, and then we're going to multiply all those in blue we're adding, and then we're going to come the other way. Multiply. Everything in red, we are going to subtract. So we got 6 times 1 times 8 is 48, plus negative 2 times 0 times 24 is 0, plus 3 times negative 2, negative 6 times 7 is negative 42. Now the red products, that's negative 2 times negative 2 is 4 times 8 is 32, but we're minusing it. That's going to be a 0. And then 3 times 1 is 3 times 24 is 72, and we're minusing that. So we got 48 minus 42 is 6, minus 32 is negative 26. Minus 72 is negative 98. So we say dx is negative 98. Now we want to calculate dy. So again, we're going to use the same matrix, but now we're going to replace the y column with these constants out there. So let's do that now. So now we're going to repeat these first two columns, and then we're going to multiply. We're going to add all of those products, and then in red, coming back the other way, we're going to multiply. multiply and we're going to subtract those products. So first we got 4 times negative 2 times 8 is negative 64 plus 6 times 0 times 2 is 0 plus 3 times negative 6 times 24, that's negative 432. And then we come back for the reds. Then we got 6 times 8, which is negative 288, but we're minusing that, right? Minus 4 times 0 times 24, which is 0, minus 3 times negative 2 times 2, which is negative 12. And we get negative 196. That's going to be dy. Now, last but not least, we got to calculate dz. And here we're going to replace the z column with these constants there. Let's write that out. So again, we're going to repeat these first two columns over here. And then we're going to multiply in blue. We're going to add those. And then in red, come back the other way. Multiply. We're going to minus those. 4 times 1 times 24 is 96. Plus negative 2 times negative 2, which is 4 times 2 is 8. Plus 6 times negative 6 is negative 36 times 7 is 210, 42, negative 252. And then coming back the other way, negative 2 times negative 6 is 12 times 24 is 240 plus 48, 288. Positive, but we're minusing that. Then we got 4 times negative 2 is negative 8 times 7 is negative 56, where we're minusing that as well. Last but not least, 6 times 1 times 2 is 12, so we're minusing 12. Then we have 96 plus 8 is 104 plus negative 252 is negative 148. This becomes a plus, and then we got 56 minus 12 is positive 48. That's going to be negative 100. Plus negative 288 is negative 388. So there's my dz. So now to get my x, y, and z values, I take my dx and divide it by d to get x. That's going to be negative 98 over that is positive 1/2. Then to get y, I do this divided by this, which is positive 1. Last but not least, to get z, I do this divided by this, which is positive 2. So there's our final answer. Done. So for this one, using Cramer's rule, we're going to start by finding the determinant of the main matrix formed by those coefficients. And then we find dx, dy, and dz to find our x, y, and z. All right, let's set up the first one. So we got all of these coefficients right in here. Now, to find the determinant, we're going to extend these first two columns over here, right? So we've repeated those values again here. And now we're going to do a little multiplication, okay? So starting up here, we're going to go multiply. Now, those three products are going to be added together, and then we're going to take these products coming back in this direction like so, and each one of these are going to be subtracted. Okay, so let's write it out. So first, these three multiplied gives us negative 5850 plus 17 times 46 gives us a negative 13,294. And then these three multiplying give us a negative 1760. All right, now for the reds, these three all negative multiply and give us a negative 560, or 5610, excuse me. But again, we're subtracting it. So subtracting a negative is going to be a positive. And then these three multiplied give us 2,210. Again, we're subtracting that. And then 16, 15, 46. And that gives us 11,040, which we're minusing. All right, now we're going to combine all of these using a calculator. And we get negative 28,544. So we're going to put that up here. Next, we got to calculate dx. So dx, we're going to start with the same matrix, except I'm replacing the x column with these constants. Let's write that out now. So once again, to calculate dx, I'm going to repeat these first two columns here and here. And then we're going to multiply. So we're going to add all of those products together, and then we're going to take these products in red, like so, those three products, and we're going to subtract those. So these three multiply, and we get negative 32,850 using a calculator, of course, plus 17, 17, 18. The negatives are going to cancel out, so we get positive 5202 plus these three multiplying, which is 9760. Okay, now let's do the reds. These three multiplying gives us positive 31110. But again, we're subtracting the red, so I'm going to still put a negative in front of it. Then these three here give us 12,410. Again, we're minusing that. And then these three, it's going to be negative 4320. But again, we're minusing that. Okay, and that double negative is going to turn into a plus. All right, let's combine everything. And we get for dx negative 57,088. Next, we're going to solve for dy. So it's again using the same exact matrix. Now we're replacing the y column with those constants. Let's write it out. Now we're going to repeat these first two columns over here. Now we're going to multiply, multiply, multiply. We're going to add all those together. And then we're going to take this product, and this product. These ones in red, we're going to subtract. Okay, let's write them out. So first we get negative 23,790 using a calculator, and then plus 57,086 plus positive 3168. Okay, now let's do the reds. These three give us 24,090. But again, we're minusing the red. So even though that's positive, we're minusing it. And then minus. Then we got negative 3978. And then last but not least, we got 44896 minus. Okay, now let's add them all together. Again, this double negative is going to be a plus. And we're left with, for dy, negative 28544. Finally, we're on to dz. So again, we're going to be taking this same matrix, now replacing the z column with these guys. All right, let's write it out. Once again, we're going to repeat column 1 and column 2 right here. And now we're going to multiply, multiply, multiply. We're going to add all those together in blue, and then multiply coming back the other way. Multiply and multiply. Let's write it out. So first we got negative 3510 using a calculator, plus negative 47702 plus negative 8030. Now let's do the reds. This is going to be negative 3366, but then again, we're minusing that, so double negative turns into a plus. And then we've got the next one. Then we got 7390, again, minusing that. And then we got 7930, again, we're minusing that. Finally, the last product is 50,370, again, we're minusing it. Okay, let's combine everything. And finally, we're left with negative 114176. All right, now to get our final answer for x, we take dx divided by d. That's going to be positive 2. To get y, we get dy divided by d, which is positive 1. Last but not least, dz divided by d to get z, and that is positive 4. So there is your solution done. So for this one, using Cramer's rule, once again, we're going to find d of the matrix with all these guys, right? And then we're going to find dx, dy, and dz. All right, let's start with d. Let's set up our matrix. All right, so again, I just used all the coefficients provided here, and now let's find the determinant. First, I'm going to repeat column 1 and column 2. Let's do that now. And now we're going to multiply down, multiply down, multiply down, right? We're going to add each of those products, and then we're going to subtract these products, right? Coming diagonal the other way. That one, and that one. All right, let's write it out. So first we have 4 times 3 times 1, which is 12, plus negative 6 times negative 4 times 1, which is 24. 8 times negative 2 times 1 is negative 16. Now for the reds. Negative 6 times negative 2 times 1 is 12, but again, we're minusing that. 4 times negative 4 times 1 is negative 16. Again, we're minusing that. And then 8 times 3 times 1 is 24, and we are minusing that. All right, and that double negative becomes a plus. All right, let's combine everything. You can see these guys are going to cancel out. 24 plus 16 is 40. Negative 16 plus negative 24 is negative 40, which means my determinant is 0. So in this case, when you get a determinant that is 0, you're either going to have no solution or infinite solution. Now, if we take a quick look at this system, okay, what you can see is that this is going to probably be a infinite solution situation. The reason why is because if you look at these first two equations, they're not parallel, they're actually identical, right? If I multiplied this bottom equation by negative 2, I'd get that exact top equation, which means they are indeed overlapping. So we can go straight to our solution. We got that 0. We can kind of jump out here and just say, cool, this is an infinite solutions situation. That's how you do it. Done. So for this one, we're meant to find the determinant using a graphing utility, so we're going to use Desmos. So here we've entered the matrix like so, and now we can just say determinant of A, and boom, it's that easy. It's 24. So the answer is 24, boom, done. So for this one, we're meant to find the determinant using a calculator, a graphing utility. We're going to use Desmos, so let's check it out. So now that we got the matrix entered, we just use this nifty feature, determinant of matrix A, and there we go. 1 is the winner, just like that. So there it is. 1 is the answer, done. So for this one, we're meant to make a system of equations and then use determinants, etc. So let's check it out. We've got two numbers. Let's call them x and y. And they say that they add up to 56. So we'll say x plus y equals 56. And then we also have this other equation. One number, let's call it x, is 20 less than the other number. So check it out. We got two equations. Now, before we set up this matrix, we want to set it up in this correct format, right? So I'm going to minus y from both sides. So I got x minus y, and then that negative 20 just stays over here. So the first matrix is, of course, going to be with these coefficients, right? So we'll just call this D. So we got 1, 1 for the x's, and then 1 and negative 1 for the y's. We're also going to have to calculate the dx and dy, but we'll get to those in a second. All right, so first, what's the determinant, right? This times this minus this times this. So that's negative 1 minus 1, which is negative 2. Okay, so we are going to get a unique solution. Now let's do dx. So dx, what we do is we replace the x column, right? We replace this column with these constants, I should say, 56, negative 20, and we leave the y's as is, 1 and negative 1. Now we calculate the determinant, this times this, which is negative 56, minus this times this, which is negative 20. Double negative turns into a plus. Negative 56 plus 20 is negative 36. Okay, so there we go. And then now let's do dy. So for dy, we leave the x coefficients, the 1 and the 1 alone, and we replace the y's with the 56 and negative 20. And then to get the determinant, we take the product of that, which is negative 20, minus the product of this, which is 56. And that's going to give us negative 76 for dy. All right, now to get our x and y values, we do the dx over d. So that's negative 36 over negative 2, which is 18, that's our x value. And then to get our y value, negative 76 over negative 2, which is 38. And that makes sense, right? They're 20 apart, and when you add them together, we get 56. So there's our unique solution. Boom, done. So check it out. We got three numbers that add up to 106. Let's call them x, y, and z. Then it says the first number, x, we'll call it, is 3 less than, we'll call y the second number. And then it says the third number, z, is 4 more than the first number. Now, the reason why I wrote these off to the side is we're going to line them up over here. I just wanted to put them here as I read them, and then we're going to reformat them. So check it out. I'm going to subtract y from both sides for this one, and we're going to leave that negative 3 over here. For this one, I'm going to subtract x. So we got a negative x. We got 0 for y, and then we got a positive z over here, and that's equal to 4. So now we got this great triple system, and now we can set up our first matrix. Again, we're going to have to calculate d, dx, dy, and dz to get these three values. So to get the first determinant, we just put in all these coefficients in down here, and now we're going to repeat column 1 and column 2 right here. Now let's move it down, and we're going to do our calculation, and we're going to do some multiplication, some products, and we're going to color code it. So we take this product plus that product plus that product, and then we're going to come back the other way, but then we're going to minus the products. We're going to minus that product, minus that product, minus that product. Okay, let's write it out. So we got 1 times negative 1 times 1 is negative 1, plus that's going to be a 0 because there's a 0 in the mix, and same with this. Now let's do the reds. So we got 1 times 1 times 1, which is 1, but we're minusing it. 1 times 0, which is 0. 1 times negative 1 times negative 1, which is 1, but again, we're minusing it. So now as we combine everything, negative 1, and negative 1 gives us a d of negative 3. All right, so now we got negative 3 for d. Now let's go to dx. So we're going to have the same matrix here, except we're going to replace that first column with these constants over here. Let's write that out down below. Once again, we're going to repeat column 1 and column 2 over here. And now we're going to multiply. We're going to add those up, those products, and then we're going to multiply, and these products we're going to subtract. So let's write it out. So first we have negative 106 plus, that's going to be 0 because of the 0 in the mix, plus another 0 because 0 times anything is again 0. All right, now let's do the reds. 1 times negative 3 times 1 is negative 3, but we're minusing that, so the double negative turns into a plus. 106 times 0 is 0. Oops, I'll write a minus 0. And then 1 times negative 1 times 4 is negative 4, but again, we're minusing that, okay? So that double negative turns into a plus. Now let's combine everything. Negative 106 plus 3 is negative 103, plus 4 is negative 99. So dx is negative 99. Now let's go to dy. So again, we're going to take the same matrix, but I'm going to replace this column with this column. Okay, let's do that now for that determinant. Now we're going to repeat column 1 and column 2. And now we're going to multiply. We're going to add those together, and then we're going to multiply the other way. Boom, boom, and boom. But we're going to subtract the products in red. So let's write this out. First, we got negative 3 plus, that's going to be 0 because of that 0 in the mix, plus a 4. And now let's do the reds coming back this way. That's going to be 106 positive, but we're minusing it. Then we got another 0. And then we got 1, negative 3, negative 1 is 3. But again, we're minusing that. All right, let's combine everything. We got negative 109, negative 112, and then plus 4 is negative 108. And last but not least, let's calculate dz. Again, taking this exact same matrix, replacing the z column. Let's write that out. So again, we're going to start by repeating these two columns over here. And now we're going to multiply, and we're going to add those together, those different products, and then we're going to come back this way, multiply, but those ones we're going to subtract. So check it out. This is going to give us, the first one is negative 4 plus, that's going to be positive 3, and then because we got the 0 in the mix multiplying, it's just going to be 0. Now let's do the reds. So that's going to be 4, but we're minusing it. That's going to be 0, and we're minusing it. That's going to be positive 106, but again, we're minusing it. So now as we simplify everything, this is going to be negative 110, right? Negative 106 plus negative 4, negative 110, negative 114, and then adding the 3, we get negative 111. That is dz. Now to get x, y, and z, so first we take dx divided by d. That's going to be 33 for x. Then we got dy divided by d. That is going to be 36 positive, right? Negatives cancel out. Last but not least, we got negative 111 divided by negative 3. And that's going to be positive 37. And just to do a quick check, right? What do these three add up to? That's 69. 99 plus 7 is 106. That's what we said. The rest match as well. That is your final answer. Unique solution. Boom, done. So for this one, we're going to create a system of equations, and it looks like we got two accounts. We're going to call them X and Y, all right? And one receives 8% interest and one receives 5% interest. And we're investing $10,000 total into each account. So the way we can think about it is like, X is the amount we're investing here, Y is the amount we're investing in that account. So we know that the two together equals 10,000. There's my first equation. And then here's the second part. So at the end of a year, you had this much, right, in your combined account. So what that means is that the interest on each, right, added together, so 8% interest of that plus 5% interest of Y equals $710. So why did I say 710 and not 10,710? Because the interest is the additional beyond the 10,000. All right. I could have also said 1.08 and 1.05 and made that 10,710. So it's like the full amount, but why not go with this? All right, now let's use Cramer's rule. Let's solve for d, dx, and dy to get our solution. So first let's solve for d. So we're going to set up a nice little 2x2 matrix with these coefficients. So 1 and 0.08 coefficients of the x's, 1 and 0.05 coefficients of the y's. And then we're going to multiply minus that product. So that's 0.05 minus 0.08, which is negative 0.03. So there's our d. Now we're going to do dx. So let's set up a new little mini 2x2 matrix. And again, now we're going to replace the x with these constants. So I got 10,000, and then I got 710. The y stay the same. We still got 1.05. Okay. Now we're going to get the determinant, we're going to multiply, and that's going to be 500 minus 710 times 1, which is 710. So that's going to be negative 210. So that's dy. Now let's get, that's dx, excuse me. And now let's get dy. So dy, we're going to make one more little matrix, and now I'm going to put in these coefficients, or constants, I should say, in the y column. So now I got 10,000 over here, 710 like so. And then we leave the x's alone, 1.08. Okay. And then we multiply 710, and then we minus 0.08 times 10,000, which is 800. And we get, let me write it over here, negative 90. okay? And that's going to be our dy. So let's box that. All right, so we got negative 0.03 for d. We've got negative 210 for dx, and then we got negative 90 for dy. All right, now to get my x value, I take negative 210 divided by negative 0.03. And since they're both negatives, we can just make it positive, and we get a nice 7,000. So the first account was 7,000. The second account, since we know it adds up to 10,000, has got to be 3,000. But let's still go our standard way, right? Negative 90 divided by negative 0.03. And there we have it, 3,000. So there's our answer. 7,000 in one, 3,000 in the other. That's how you do it. Done. A theater needs to know how many adult and children tickets were sold out of 1,200 tickets. So by the way, we can immediately set some designations here. We know we got two categories, child, and we'll say Y is adult. And I like to make a little table like this so we remember what's what if we need to at the end. And then it says first, this is the number of tickets for child, number of tickets for adults. And we know the total, meaning the two added together, is 1,200 tickets. Now it gives some more information. It says $5.95 per child ticket and $11.15 per adult ticket. Okay. And then it gives us a final amount of the revenue. How can we use this? Well, if I can create now an equation involving the revenue, and I can say $5.95 per every child ticket times the number of child tickets plus $11.15 per adult ticket times the number of adult tickets equals that total revenue. Now we got enough information to solve this. And when again, using Cramer's rule, we need d, the determinant, dx, and dy. So let's set it up now. Let's first get regular d. That's going to be taking these coefficients. So we got 1, 5.95, 1, and 11.15. Let's calculate the determinant. So we multiply, that's 11.15, and then we multiply these and we minus that, that's 5.95. And that's going to give us a determinant of 520. Okay, so that part's done. Now let's do dx. So we're going to set up another matrix, okay, but now we're replacing the x column with these numbers. All right, so we got 1,200, we got 12,756, and then the y's stay the same. We still got 1 and 11.15. Now we're going to take this product minus this product, and we end up with 624. So dx is 624. Okay, we're just going to make a little bit more room to do dy. So now with dy, we're going to set up one more matrix 2 by 2. But again, now I'm going to replace the y column with those constants. So 1,200, 12,756 here. And then we leave the x's as is, 1 and 5.95, like so. Okay, and then we take this product minus this product. Let's do it in Desmos. And we get 5,616. So there we have our dy value. Let's put them up here. So now to get the number of child tickets sold and number of adult tickets sold, first for child, we're going to do dx divided by d, and we get 120 for child, so 120 children tickets. Now, we already know it's going to be 1,080 because the two have to add up to 1,200, but let's do it anyways. Now it's dy divided by d, or 5,616 divided by 520, and we get, like we predicted, 1,080. So 1,080 adult, 120 children. That's how you do it. Done. You decide you paint your kitchen green. You create the color of paint by mixing yellow and blue paints. You cannot remember how many gallons of each color went into your mix, but you know there were 10 gallons total. Okay, so again, we got blue and yellow, but I'm going to still call it X and Y. And then it says, additionally, you kept your receipt and know the total amount spent was $29.50. And then we know that each gallon of yellow costs $2.59. Let's put that here. Each gallon of blue costs $3.19. Let's put that here. All right, and X and Y are representing the number of gallons. Okay, so we got our first equation, X plus Y, the number of gallons total is equal to 10. And then we got our second equation with the total amount we spent, right? And the way we're going to get that is we got $3.19 times the number of gallons of blue plus $2.59 times the number of gallons of Y, and that equals the total cost of $29.50. All right, now we can start to calculate our determinants. So again, we're going to need d, dx, and dy. All right, so let's do d first. Let's do it right here. Okay, so we're going to plug in these coefficients into this matrix. So we got 1 for x and y, and then we got 319 and 259 for x and y in the bottom equation. And then we multiply that minus the product of that. So that basically becomes 259 minus 319, which is negative 0.6. So there's our D value. Now let's do dx. So we keep the exact same matrix in terms of the y values, 1 and 2.59, but then we plug these guys into the x column. We got 10 and 29.50. Okay, so then we take this product minus this product. So that's 25.9, excuse me, minus 29.5. And that gives us negative 3.6 right here. Let me make that decimal clear. Okay. Now, last but not least, let's do dy. Okay. So dy, we put in these guys into the y column. So 10 and 29.5 like that. And then we still have the 1 and 319 right here. Okay, great. And then now we do this times that minus this times that. So that's 29.5 minus 31.9, and that is going to be negative 2.4. Now to get my x and y value, I do dx divided by d for x, which is going to be negative 3.6 divided by negative 0.6, like 36 divided by 6, which is 6. So we got 6 gallons of blue. It's got to be 4 gallons of the yellow because, 6 plus 4 equals 10. But just to be safe, negative 2.4 divided by negative 0.6, that's like 24 divided by 6, which is indeed 4. So we got 6 gallons of the blue, 4 gallons of the yellow, and that's how you do it. Done. Your garden produced 2 types of tomatoes, one green and one red. So let's just put in a little table here, green and red. I'll call that X and Y, okay? The red weigh 10 ounces and the green weigh 4 ounces. And then you have 30 tomatoes total and a total weight of 13 pounds and 4 ounces. Okay, by the way, this is in ounces, so let's maybe make that clear here. All right, so if we have 30 tomatoes total and X and Y are the number, and that's what we're solving for, right? How many of each do you have? We have our first equation, which is just X plus Y equals a total of 30, all right? Now we have a second equation for the total weight that we can create, which is the total weight of the green is 4 times the number of green plus 10 times the number of red. And what does this equal? Should we say 13 pounds and 14 ounces? No, we can't do that. It's 2 different units. So we got to convert 13 pounds to ounces. And we do that by saying 13 times 16, which is 130 plus 78 is 208. Plus that 14 is 222. Now we have 2 equations, and now we can use Cramer's rule and get d, dx, and dy. Okay, let's set up the first matrix to get d, and we're just going to take these nice coefficients here. For the x's, 1 and 4. For the y's, 1 and 10, and let's get the determinant. 1 times 10 is 10, minus 4 times 1 is 4, which gives us 6. So d is 6. Now let's do dx. So I'm going to use almost the same matrix, except I'm replacing the x values, the 1 and the 4, with these guys. So we got 30, 2, 2, 2, and then the y stay the same. What's the determinant here? 30 times 10 minus 222 times 1. That's 300 minus 222. So that determinant is, what is that, 78, I believe, for dx. And then now for dy, okay, we're going to keep the x's the same with the 1 and the 4. And now the y column is going to be replaced with the 30 and the 222. Okay, so I'm going to do 1 times 222, which is 222, minus 4 times 30, which is 120. And that gives us a dy of 102. Okay, now let's get our x and y values, which is the number of green and red tomatoes. So to get green, we do this divided by this, 78 divided by 6, which is 13. So we got 13 green. And then we have, to get the number of red, we do 102 divided by 6, which is 17. So 17 red. So that is how you do it. Done. At the same market, the 3 most popular fruits make up 37% of the total fruits sold. Strawberries sell twice as much as oranges, and kiwis sell 1 more percent point than oranges. All right, for each fruit, find the percentage of total fruits sold. Okay, so we're going to say strawberries, oranges, and kiwis, okay? And I love to make a table like this because we can always look back and be like, oh, this variable links to that, etc. So we'll just say x, y, z. That's kind of arbitrary. Okay, and now let's put these together. So we have our first equation, which is the 3 of them together. And each of these represent percentages, okay? So we'll just keep them as whole numbers, representing the whole number percentages. So x plus y plus z equals 37%. Notice I don't make it 0.37 because I could, but it's pointless. I may as well just represent it as 37 as a whole number, easier to show later on. Okay, then it says strawberries sell twice as much as the oranges. I always write it over here because now I'm going to put it over here, but I'm going to translate it, meaning I'm going to have it so everything lines up. I'm going to subtract 2y from both sides, and then it's all equal to 0. Okay, then the final relationship is kiwis sell one more than oranges. So again, I'm going to subtract y from both sides, and I got negative y plus z is equal to that 1. Okay, now we have our nice little triple system, and with that, we can now calculate d, dx, dy, and dz to use Cramer's rule. All right, first things first, let's make a little room, and let's get our first D matrix set up. So we're going to set it up like so with these nice coefficients. So we got 1, 1, 1 on the first one. We got 1, -2, and 0 for the second one. And then we got 0. Again, I'm choosing 0 because there's no z. I'm choosing 0 here because there's no x, -1, and 1. Now we're going to repeat these first two columns, 1, 1, 0, 1, -2, -1. And now we are going to multiply. Let's make a little bit more room. So we're going to do that product plus that product plus that product. So the blues are sums or positive. And then we're minusing that product, and that product. So the reds are what we're subtracting. So here we have -2, then we have plus 0, right, because of the zeros. And then we have plus -1, because 1 times 1 times -1 is that. And now we got the reds. 1 times 1 times 1 is 1, but we're minusing it. And then we got a 0 and a 0. Again, 0 and a string of numbers being multiplied, it's just going to zero it out. So we got -2 minus 1 is -3 minus 1 is -4. So D is -4. So now to get dx, we're going to do the same matrix here, but we're going to replace the x column with these constants. So let's do that down below. Next, I'm going to repeat column 1 and 2 over here. And then we're going to take this product plus this product plus this product, and then we're going to minus that product minus that product minus that product. Okay, let's write them out. So first we got 37 times -2 is -74, right? Times 1 is just that. And then we got plus, that's going to be 1 times 0 times 1, which is 0, plus 1 times 0 times -1, which is 0. Now let's do the reds. We got another 0 in the mix there. We got another 0 in the mix there. And then last but not least, we got 1 times -2 times 1, which is -2, but we're minusing it. That double negative makes a plus. So basically, we just got -74 plus 2, which is -72. Now we're going to go for dy, again, going back to this matrix, but replacing the y column with these constants. Let's write it out down below. So again, I'm going to rewrite column 1 and 2 over here. And then we're going to add this product, and this product, and then we're going to subtract this product, subtract that one, and subtract that one. Okay, let's write them out. So because we got a 0 in the mix, that's 0, another 0 in the mix, that's 0, and then all ones, so that's 1 when we multiply, then minus 37 times 1, which is 37. Again, we're minusing it because we minus the reds. 1 times 0 times 1 is 0. 1 times 0 times 0 is 0. Which means that our dy is 1 plus -37, which is -36. Last but not least, we need dz. So again, we're going to take this guy, but we're going to replace the z column with these constants. Let's write it out. So then again, I'm going to repeat column 1 and 2 right here. And then we're going to multiply in blue. We're going to add those. And then in red, coming back the other way, multiply, but we're going to subtract those in red. So here we got -2 for the first, plus that's going to be 0 plus -37, right? 37 times 1 times -1. Now the reds, we got triple ones, so that's 1, but we're minusing it. We got a 0 in the mix, so we're minusing that. And then we got another 0 in the mix, so we're minusing that. Okay, so all we got is a -2 and -1, that's -3, plus -37 is -40 for dz. Now we can calculate the number of strawberries, oranges, and kiwis. Again, it's nice that we have this little chart up here. So to get strawberries, we do dx divided by d, which is -72 divided by -4, which is 3618. So we got 18 strawberries. Then for oranges, which is why we get -36 divided by -4, which is 9. For oranges, that's Y. And by the way, these represent percentages. So it should be 18%, I should say. 9% make up oranges. And then kiwis. And by the way, this adds up to 27. So kiwis should be 10. But just to see that it still works out with Cramer's rule, negative 40 divided by negative 4 is indeed 10. And that's a percent, right? So 18% strawberries, 9% oranges, 10% kiwis. That's how you do it. Done. A movie theater sold tickets to 3 movies. The tickets to the first movie were 5. Okay, and by the way, we're going to write this out right now, right? We got 3 tickets, so we got 3 variables, 3 movies, excuse me. So the first one are $5. The second movie, they cost $11. And the third, they cost $12. And then we know we got 100 tickets sold to the first movie, and the total number of tickets sold was 642. Well, this is interesting because we already know that X is just straight up 100. And since the total number of tickets sold is 642, I already know that Y and Z add up to 542, right? That's 100 less than the 642 because we're just removing it for X. So it's interesting. The reason why I'm saying this is because it's actually, we can do this as a 2-variable equation system as opposed to 3-variable because we already know X for some reason. They gave it to us. So, hey, that makes it easier. Now we can use this to get our last equation. But by the way, again, let's remove X from this amount. And I can do that easily because I know that the first movie, they were $5. 100 times 5 is $500. That's the revenue made for that. So if we remove 500, we have 6274, okay? And this will be the sum of Y, how much we make for Y, right? 11 times Y plus 12 times Z, right? Don't even mess with the X, we already know what it is. Okay, so now we can use this, solve this using Cramer's rule. First, I got regular D. Let's write it out. We want D, dx. Actually, we don't even need dx, sorry. We're just gonna say D, dy, and dz, all right? And now let's, because we don't need a dx because we already know x. So let's put this in first to get d. So we got 1, 1, those are these coefficients, and then 11 and 12. So to get the determinant, we do that times that, 12 minus that times that, which is 11. 12 minus 11 is 1. So that's the main determinant. Okay, now let's do dy. So with dy, what we're going to do is we're going to replace the y column with these guys, these big numbers. So we got 542, 6274. And then over here, we keep the z's as 1 and 12. And then to get the determinant, we multiply those guys minus the product of those guys. So using the calculator, we get 230. So dy is, let's put it up here, 230. And then last but not least, we need dz. So we're going to keep the y as is coefficients with 1 and 11, replace the z's with 542 and 6274. And let's get the determinant of this. So we do this times this minus this times this. And we get 312. So dz is 312. Okay, now to get my values right, to get y, I say dy divided by d, but d is just 1. So it's basically just 230. And we already know X is 100 tickets for the first movie, 230 tickets for the second movie, and then DZ, which is the same as Z, because it's 312 divided by 1. So then we got 312 sold to the third movie. So that is how you do it. Done. For the following exercises, use this scenario. A health-conscious company decides to make a trail mix out of almonds, dried cranberries, and chocolate-covered cashews right here, right? And it says for the hiking mix, there are 1,000 pieces in the mix. Okay, so let's make some variables here. But first, let's read a little more. Containing this much fat and this much protein. And then it says if there's the same amount of as almonds as cashews. Okay, wait, that's very interesting. So that means almonds and cashews, we can use the same variable because it's the same amount. How many of each item is in the trail mix? All right, so we can start by just labeling, writing this out. Almonds, cranberries, and cashews. And we got X for almonds, Y for cranberries. But again, almonds and cashews are the same. So why not reuse X? This is going to be pretty cool because what normally would be a 3-variable system, maybe we can make it a nice 2-variable, make this simpler. Okay, so now let's make some equations here. We know that if we add up all of the pieces, meaning X plus Y plus X, or 2X plus Y, we get a nice 1,000. And then we can take this fat thing, right? And we know that it's 390.8 grams of fat. And now we have to take the amount of grams of fat per each of these. But notice this 10. This means it's 6 grams for 10 almonds, which means it's 0.6 for 1 almond, 0.7 for 1 cashew, okay? And 0.002 for 1 cranberry. So we can add these together. By the way, 0.6 and 0.7 make 1.3x. And then we've got plus 0.002y, and this equals 390.8. Now, let's move it down. And here's the thing. I don't need this third relationship because we've reduced this to a 2-variable system. I got 2 equations with 2 variables. We're good to go. So now we need to get d, dx, and dy. So let's set up our first matrix here with the values over here. So we got those coefficients 2, 1, 1.3, and 0.002. Let's calculate the determinant. So we multiply there and we get 0.004 minus that product, which is 1.3. And we get negative 1.296. All right, there's my d value. Now let's get dx. We take that same matrix and we are going to replace the x column with these constants. So we got 1,000 and we got 390.8, and then the y's stay as is, 1 and 0.002. Now let's calculate the determinant, that product minus that product. Let's do it in Desmos. And we get negative 388.8. And that's our dx value. Last but not least, let's do dy. Let's make a little room. Let's put in dy here. So here we keep the x's as is, 2 and 1.3. Replace the y's with these guys. So we got 1,000 and we got 390.8. Okay, then to get the determinant, we go this guy minus this product. Let's do that in Desmos. And we get negative 518.4. So now to get my value for x and for cashews, so it'll be almonds and cashews because they're both x, we do this value divided by that value, and we get a nice 300. So that means we've got 300 almonds and 300 cashews. Now I know that they all add up to 1,000, so cranberries should be 400, but let's just do it anyways. So we got this guy divided by this guy. Let's check it out. And there we have it, confirmation. So it is 400 cranberries, and that's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.